Hello, today we're going to talk about Mart Sort. Now, why should we use Mart Sort? Obviously, there are some benefits to it. The first being it has a very good runtime, which is n log n, and it does stable sorting. Stable sorting basically means it gives the right precedence. For example, if there is two Charlies in my list, and whoever came first goes to sit in front of the other Charlie. That is what stable sort means. Now, the disadvantages of merge sort is even if the list is sorted, the program will run. The merge sorting will be done. So the program doesn't understand when the list is sorted. So it's still gonna run. That's a problem. And it uses a lot of memory. Going forward, you'll see why I say that. Now, the algorithms used for the merge sort is the first being is if it is only one element in the list, it is already sorted. You can see the 88 and 56 from here. Basically, if it has only one element in the list, it is already sorted as because, well, you cannot compare with anything else than itself. It is bound to be sorted. So the list, whichever list we have, the second algorithm is basically we have to divide it up until to the point where we cannot divide it anymore. That means we only end up having one list, as you can see, 88 and 56. And then when we have divided all into smaller lists, for example, only list containing one element, we have to start merging the smaller list. Now, let's look at this array list. Here you can see this is an unsorted array list, and now we just have to go through, let's say, how do we go about fixing and making it sorted? Well, uh, in Mart sort, the first thing that happens is that we have to divide everything like the list in half, and then again that part in half, and then again those parts in half until up until we get only one uh, uh, elements in each list. And let's say we have this list and it stays in the memory, it doesn't go anywhere, and that's the problem that I was talking about, that it uses a lot of memory. If it has a very big array list, then it's gonna still be safe. And upon dividing it, the lists that are being created will still stay in the memory. Then now when we have it, let's say we'll only work on one half at a time so that we can properly understand what goes behind merge sorting. Now, a new list is created, as you can see, from one half of the mm, total list that was initially created. Now, this secondary list, we have to have it once again because, well, it still didn't have like one element containing list. Now we have created another list, as you can see, of 22 and 1. Now, it still has to be divided, as it can be divided, so it will be divided to two more lists. And as you can see, two more lists has been created. And now the algorithm we've been talking about is when there is a list containing only one element, we can compare them easily. Now we just compare 22 and 1, and we get that, yeah, well, 1 is bigger, 1 is smaller than 22, my bad. So now we just update the previous list, and the two other lists that were created is deleted. Now we go back to this second list that we have with four elements in them. And then we take a look at the right side of that, which is minus 5 and 65. Now we have to divide it again, and then we compare minus 5 and 65, and we see that, well, the previous list was sorted. Now this uh, this two lists will be merged into this list, which is basically this is what's going to happen. The 1 and minus 5 is compared, and minus 5 is being stored in the second list, and then 1 and 65 is being compared and stored. 1 is being stored as 1 is smaller than 65. Then 22 and 65 is compared, and 22 is stored. Then 65 just goes without uh, it having to be compared with anything else. Now we look at the right side of the initial list we started with, and then we look at its left bit, like we previously did. And as you can see, we compare 13 and 7, and then we get 7 and 13 as in a sorted list, and the other two lists are deleted. Now we look at the right bit, which is 19 and 2, then we separated it further. Now we have sorted lists here, 19 being one and 2 being another. Now we compare the two lists, and we see that 2 is greater than 19, 2 is smaller than 19, so 2 comes forward. And now, as you can see from this, that 732 and 19 now are to be compared, as we have two sorted lists now. Now we have to merge them. Now, when we're going to merge, we have to compare each and every element, starting with 7 and 2. So when we compare 7 and 2, we see that 2 is smaller than 7, so 2 is placed in the first index of the list. Then 7 and 19 is compared, and 7 goes to the second index, and then 13 and 19 is compared, and 13 goes, and afterwards it's just 19. Now the lists here are deleted, and as you can see, uh, the the list here, it's sorted, so we can merge them into the bigger list. Now we compare minus 5 with 2 and see that minus 5 is obviously smaller than 2, so minus 5 goes into the first index. And we compare 1 and 2 and see that 1 is smaller, so 1 goes into the second index. And this carries on. As you can see, 22 and 2 is compared, 2 goes up. 22 and 7 is compared, 7 goes up. 22 and 13 is compared, and 13 goes up. 22 and 19 is compared, and 19 goes up. Now, as you can see, we don't have any other element in the second list to check from, so there is no comparison since it's in the same list. Now, 22 just directly goes, and 65 directly goes. Now, all the other lists are deleted, and we have a sorted array, as you can say. So we started from this unsorted list, and then we went up to this sorted list. Now, this is an overview of how everything happens simultaneously. As you can see, there's this list, and there's this list containing 1, 2, 3, 4, 5, 6 elements, and it's just divided halfway through. 1 and 5 being separated from 3, and 4 and 2, 6 are separated from 4. So it just goes on up until everything is divided, and everything is sorted. When we call it sorted, it's just a list containing one element. Obviously, a list containing one element is always sorted. From there on, we just keep on merging. As you can see, 1 and 5, we compare 1 and 5, and we get 1, 5, which is the proper order, as in 1 is smaller than 5, and then we compare 1, 5 with 3, and we get 1, 3, 5. And same with the right hand side, as you can see, 4, 2, and 6, we get 2, 4, 6, and then we get the two lists where we compare them, and we get the sorted list. So 1, 2, 3, 4, 5, 6. Well, if you liked, please subscribe.